All right, class, this is part 2 for this week. So I looked at this again, and right here in this output on the principal component analysis in the example in the textbook, it says that they title it life satisfaction for the first scale because they look at the items in their scale that has the highest factor loading score, and that's where they name their subscales. So I think in the slide set here on the example in the textbook is you looked at the highest factors is 0.69, characterization of life as a whole, and then they look at this daily activities as 0.69, and then expectation of everyday life as 0.688, and then 0.647. And then they eventually call this subscale as life satisfaction subscale. So these are the items that they looked in their they included in their subscale, and then they also conducted Cronbach alpha, plugging in this specific items in their scale, because I think originally this is I'm trying to remember now how many items that they have in their item bank from the very beginning. So I think they have more than, let's see, how many subjects were there? 170, maybe they have. I'm trying to remember now from the very beginning in their example. They said that they have a data set that includes 30 initial items. And so they have 30 items. And so that's quite a lot in their inventory of personal attitudes. So here, when we looked at the final factor that they choose in 4, I think because this is there's a cutoff here, we don't see what else are at the bottom. So, because it doesn't make sense to me that the 0.1, 0.19, 0.36 are the factors for self-love. They call this as the second subscale is self-love, the third subscale is reactivity, and then the fourth subscale is pessimistic worry. I think the limitation of the slides that are shared by the authors of the book is that it did not show all the 30 items. So these are the items here on the left are reflective of what I would call life satisfaction. They make sense. But for the subscale number 2, which is self-love, right here, if we follow the rule where it's the highest score of the first item, so this is 0.647. So the highest score in the first factor is actually 0.695. So that's daily activities. That didn't make sense. So they choose, I think, the themes of this items that loaded into the first factor. But here, if it's self-love, there must be a continuation at the bottom of this SPSS output that we are not seeing, because I don't see in the wordings in the among the 30 items that were included in the analysis. I don't see self-love, and I especially here on factor number 4, I don't see any supportive statement in the item development that would mean pessimistic worry. So I I believe that the 30 items should be on the left-hand corner here. And so I just want to tell you that that is likely the scenario here. I see one chat, so I want to make sure. Oh, Miss Saniel, I will answer that later on. Okay. So let's do a quick look on the acceptability E-scale. So right here, the first printout would be the correlation matrix. And as I covered last week, let's go this very quickly. How easy was the program and how easy was this program? We'll have 1:1 correlation, but what's important is to look at the correlation of the item to the other items. And this is how to interpret that. So the strongest item that has a correlation with how easy was the how understandable. And that has a lot of implications later on when we analyze the factors, because the items that correlate with each other means that they share that variance. It accounts for a construct, and so that's why they have high correlation, because they are hitting in one construct. They're supporting each other to be the determinant of to be considered as determinants to a construct. So pay attention when you look at this on which items correlates very highly with other items, because that's the one that will group together later on. So that's the most important part when you analyze correlation matrices, is look at the items that highly correlated to the other items. So for how easy, it was the how understandable that correlated very strongly to that. And then how understandable is the question. If you look here, it highly correlated with how easy was the program, because that's 0.46. And then how helpful to you was this computer, and it has a high correlation of 0.581 to the overall satisfaction, so helpfulness and satisfaction, and so on and so forth. So this is just to let you know on how to interpret correlation matrices, to look at the other items that has a very high correlation, because correlation, again, is a measure of strength and the strength of association and the direction of the association. So it looks like these are all positives, so there's no contradictory items in the scale. And then it shows that it has very different correlation coefficients, and that's your the R values, and that's how you interpret this correlation matrix, is to look at which of the items have very high correlation values, so that it gives you a flavor of what to expect later on of which item will pull together. And so, and it has different statistical significance as well. Now, the KMO Bartlett's for the acceptability scale was from us was 0.764, and the cutoff was 0.8, and so we thought that it passed the KMO test, which is the sampling adequacy. So we thought that we have an adequate sample. We actually have over 600 in this study, so we were not worried that we will not achieve a good KMO score. And then for the Bartlett's test of sphericity, we obtain a statistically significant values of 0.001, which means that the values that are in the diagonal are zeros. That's the null hypothesis for the Bartlett's test of sphericity. The communalities, you actually need to, so this is h squared. It is represented, communalities is represented as h squared. And as I've said earlier, this will not equal to 100%, because if you square all these numbers in the final extraction, so 0.592 is going to be 35%, 0.294 will be 8.6%, 0.47 would be 22.6%, 0.485 will be 23.5%, and then 0.349 will be 12.18%, and then 0.741 will be 54.9%. So if you add 54 plus 12 plus 23 plus 22 plus 8 plus 35, these communalities will not be 100%. So there's it will be more than the 100%, because this is actually the percentage that the item is accounting for in relation to the total item. So this is not additive or summative for the communalities. Whereas the rotation sums of square loadings will give you a cumulative percentage of the variance that's explained by the factor. So this is looking at factors. This one is looking at items. So in the in our study way back in 2006, there were two factors that were reported, which surprised me. I trying to remember this, because when I look at this now and I said, this is not, I gave this data to the statistician and, at the University of Washington. And what I got was one factor. And here I am, I'm looking at the raw data, and then I'm running it now as 10 years later, and I'm looking at, there's actually two factors, because the eigenvalues was more than one. So this really, quite honestly, puzzled me, because I remember back in 2006, I didn't have this sophistication of running my own statistics, and what the printout that was given to me by the statistician was that there was only one factor that has a score of 1. So this is really quite important to pay attention, because now I'm beginning to think maybe our raw data from the very beginning is, maybe there was no difference with acceptability E-scale with the US and the French version, because as I looked at this now, what I got from my mentor was really the raw data that she gave me that's de-identified and everything. And this is the first time that I'm running it myself. The output that was given to me by the statistician, because I was a naive PhD student, I didn't know how to run these things. So this is actually showing that there's two factors. So now I'm beginning to think that I don't know what happened with the analysis with the statistician back in 2006, but definitely I reported that there was only one factor, because what I saw at that time was there was only one that made to the cutoff of eigenvalue of 1 or higher. And the scree plot right now is showing you that there's definitely two factors, because the arbitrary cutoff for eigenvalue is 1, and that's how you will make the decisions of how many factors you're going to retain in your scale. So it looks like we have, if if this is the raw data that I got from my mentor way back in 2016, and it's still in my computer, the printout definitely that I got from the statistician was not the same. I only got one factor, and that's why we decided, and we call this as a unidimensional scale. But right now, if I'm going to report this study, and I have two factors that have a score of greater than one eigenvalue, I would definitely report the acceptability E-scale as a multidimensional, because there's two that made to the cutoff of eigenvalue of 1. So I look at the publication of the French, and they call their two factors as the satisfaction subscale with 3 items and the usability subscale, which also has 3 items. And then when they run their Cronbach alpha, it passed the minimum requirement for internal consistency, which has to have a Cronbach alpha of 0.7 or higher for a new tool. So in the French version, they have satisfaction subscale and they have usability subscales. And in our report back that we published in the Applied Journal of Nursing Research, we only have one factor, and that was the acceptability scale. So this is quite puzzling to me, but perhaps what I have is sometimes statisticians will clean up the data and will organize the data, and then they will remove, they have a lot of statistical procedures that remove missing cases. So I'm not saying that the statistician made a mistake, because that's really wrong. It's just that statisticians do have a lot of technique that they do to clean up and organize data. So I just want you to know that right now, when I run my own data based on what I've got, and I haven't done any cleaning or organizing, this is still the raw data. So based on raw data that's unclean, quote unquote, because that's not the right word. I haven't done any of data organization or data management or data cleaning for this data sets that's was given to me. But statisticians do a lot of this cleaning up of data. So maybe the statistician way back in 2006 had deleted or excluded cases that are incomplete, and what they have came up with only one factor that has an eigenvalue of 1, and that's why we ended up with just one dimensional acceptability E-scale. But right now, if you look at this, there's really 2 factors, and according to the book is you look at the highest area of the items that loaded into that factor, and that's where you will name your subscale. So for this, I was looking at this, and it says, how would you rate your overall satisfaction? It's 0.8. So this would have been named as the satisfaction subscale. And then right here, the highest item that loaded in the second factor is 0.641. So this is how easy was the computer to use. And so I would name this subscale then as, so it's easy. It has something to do with usability. And so that's what made me look at the French. I said, they name it satisfaction and they name it as usability. And so when I look at this, it looks like it has it looks like the French and the US version of the acceptability E-scale, if it's, because I didn't know what the statistician did to clean up the data, but what I've got by just looking at the raw data, it looks like we have actually found similar two factors, and that they named how easy based on this result of the factor matrix, which is the most important part, because this is after they rotated. This is rotating only the items that made it to the factor. So this is 0.641, and so how easy would definitely be named as usability. It's the technology acceptance model, or the TAM model, is acceptability. There's two determinants for the technology assistance model, and I was just looking at that again in the TAM model of theory. The TAM model was published by a scientist who studied at MIT, which is a very prestigious university, better than Harvard, I would say. So in the TAM model, there were two major determinants in that study. And these two determinants of the TAM model, TAM, let's take a look at this again. Yeah, let's one more time. So this is the determinants of the technology acceptance model is perceived usefulness. And then, so usefulness is a very important construct in acceptance. And then the second determinant was the perceived ease of use. So there were two determinants of this technology acceptance model. So this really is quite consistent with what we found here. If the two determinants of technology acceptance model, this is very highly theoretical, but quite fascinating for me. And as one of your classmates says, listening to my lecture is like watching a teleserie that it just keeps on going and going, and there's so many twists in the story. So, but this is something that you would remember actually. If we keep on being very so technical, it's very boring. So I'm trying to really put a nice presentation and put this in a very contextual manner. So if you look at this, I mean, this is, as a scientist, and I'm hoping that you will mirror your interpretation later on of your data, is for you to really be a scientist, and you keep on digging and digging and digging. It's like, what is the truth? And so these are the things that I'm digging. I'm trying to seek the truth, because it really bothered me that why did I have one unidimensional and I published it back in 2006, and then I'm running my own stat now and I have two factors and it should be multidimensional. And then I dig on the technology acceptance model that was published by Dr. Fred Davis, actually, it was his dissertation at MIT. That's the Massachusetts Institute of Technology. And in my opinion, it's definitely the most prestigious university in the world. And I would put it as number one, and I put Harvard as number two. So This, based on this model then, and looking at the raw data, easy is definitely consistent with the technology acceptance model, but the overall satisfaction, if we look at the determinants of, if we look at the determinants of the TAM model, this is where we have two determinants. It's perceived usefulness, and then the other one is so perceived ease of use. And quite very interesting. So the satisfaction part of the technology assistance model and let's look at this. The perceived usefulness. So it's your perceived usefulness, and then will be free of effort. So this is perceived usefulness. I was trying to really look at the explanation of dissatisfaction because that has the highest score in the rotation factor loading. The easier the system uses, the most useful it is. So TAM theorizes that an individual behavior, intention to use, is determined by two beliefs. So the two are perceived usefulness and then perceive. So it's the perceived usefulness and then the ease of use. So it's your perception of how useful this, and then it's how easy it is for you to use the technology are the two determinants of technology acceptance model. So if we look at this exploratory factor analysis, how would you rate your overall satisfaction with this electronic self-report assessment as perceived usefulness? And then would I call the second factor, how easy was this program to use, is the ease of use. And so this is really fascinating because this would tell you how would you rate your overall satisfaction. This is now the perception. So the perceived usefulness is, so the TAM model quite explain what's going on with this factor matrix. In the rotated factor matrix, which has the 0.834 is rate of overall satisfaction. And then how easy was this program was 0.76. So this is really quite fascinating for me. And if you choose then which of the three has the highest score for this, how easy is 0.49 would be how understandable. And then the next one would be the highest is 0.261. So it would be the amount of time it took to complete the program. So I will choose the 3 factors as my ease of use. And so this will be usability item in the scale, in the usability subscale. And then for the perceived usefulness, which is the satisfaction, or the French actually call this as the satisfaction subscale. Let's take a look at the French. See, they call this the satisfaction subscale. They have 2 subscale, and that is their satisfaction subscale and then the usability subscale. So they named the subscale based on the first item with the highest loading, which talk about satisfaction. And this is the perceived usefulness. So that's how you're going to interpret this. It's very complex. And then we run the, I have about 5 minutes. So let me just do this then. We have easy. We have understandable. This is the, it says that it's the rotation factor matrix that we need to go by. Understandable. And then let's take a look at an amount of time. So easy, understandable, and then amount of time. So let's run. Let's go back to the original raw data. And this is your CDU. And this is our data sets. Actually, I put it under slides because I know that we will access. So here is the acceptability Esra scale. So let's do a Cronbach alpha, because that's the last step in exploratory factor analysis, is for you to run what would be the Cronbach alpha, which is the internal consistency or the reliability. No, actually, I don't want that. And all right. This is strange because we are always able to open this, and now it's and let's go to desktop CDU consulting first. CDU, and then we go to slides. Okay, my computer is slow. Hold on. It's thinking. I hope it's not freezing. My computer is actually complaining now. I have opened so many files. Hold on. So that would be the last step of exploratory factor analysis, is once you identify the items that belong to a factor, what you're going to call now a subscale, is you need to run your Cronbach's alpha, and it needs to have a 0.7 or higher for it to be considered as a reliable subscale. So let's close this for a second because my computer is freezing on it. Open. Let's open data. Be very careful. My computer just doesn't like if I click or double click so many things. Wow. It's really freezing on me right now. Hold on. Okay. This is what you call technology. All right. What about if I will just send you later in the email as a follow-up? I will run the Cronbach alpha for the items on how easy, how understandable, and what's the amount of time acceptable, because these are the 3 factors for the acceptability E-scale that we're going to call as usability. And then for the satisfaction, which the French were calling it satisfaction subscale, the other 3 items in the tool will be, I will send you an analysis as well. All right, so let's take another 15 minutes break. It's about 9:40. We will catch up in 15 minutes. So let's say that would be 9:55 my time. And let's see, there was a chat message. The correct answer is yes. Yeah, the Cronbach alpha is the statistics to use to determine the reliability of a tool or a subscale of a tool. Okay, you can do a Cronbach alpha for the entire, which you plug in all the items in the scale, but you can also plug in select items in the entire scale, and you call it a subscale, and then you run the Cronbach alpha, and if it has 0.7 or more, then that is considered as an adequate subscale of a scale. Okay. All right, I will catch up with you in 15 minutes, and we will start structural equation modeling, and I will email you later on the subscale Cronbach alpha. Okay? All right. See you in 15 minutes.